Good morning. It's time to explore our neighborhood in space. Take a look at this picture. Nice blue sky, a little bit of clouds. I would like you to see how many crescent shapes do you notice in this picture? All right. If you don't know what a crescent shape is, that's all right. Think of it as a sliver. A lot of times we describe the sliver of the moon being visible as a crescent moon. So that kind of only partially lit circle, just the outer edge. How many of those do you see? I see 1 and 2. Now, if this is a sky here from Earth, what on earth could be making 2 of them? Is this one somehow a fake image, an illusion? This isn't Photoshop. It's not fake at all. What we're seeing is a crescent of the moon right here, very, very large because relatively the moon's pretty dang close. And then right here, this is the crescent of Venus, much, much brighter, farther out than from the Earth, much farther from the Earth, as a matter of fact. But how do we get these crescent images? We're going to start by just discussing our local moon, okay? That is the big, massive body that's out 256,000 miles from the Earth, but orbiting around us. It takes about 28 days for it to do a complete orbit, and the entire time it's out there, it's always bouncing light from our sun. That's what makes it appear to shine. Remember, the only thing in our solar system that actually gives off light is the sun. Being able to see anything else is because everything out there behaves as a mirror for the sun's light. This is my favorite picture I have ever taken of the moon, back from behind the barn where I grew up. Of course, I didn't take it all that long ago. I didn't have a good enough camera till recently. But you can see this very bright ball, and that very bright ball has captured the attention of people for thousands, maybe even hundreds of thousands of years. But it wasn't until fairly recently we started to really make good, detailed scientific observations, specifically with a person named Galileo Galilei just over 400 years ago. Now, Galileo Galilei is an Italian guy. This is an oil painting of him. He doesn't look very happy. I couldn't find a happy image of him, but he did enjoy his work. Among the many things that Galileo did, he observed our local solar system, specifically focusing on those 2 things we already saw, Venus and the moon. But the moon is what we're going to focus on for today. So Galileo Galilei lived between 1564 and 1642 AD. That's a nice long life back then. He was able to observe the moon with his own homemade version of a telescope. Now I say a homemade version of a telescope because telescopes are different now. His were made out of ground lenses that would focus light from a distant object into an image he could see. We have telescopes like that. They're just made a little bit different. Our larger telescopes are huge reflector-based telescopes that use more mirrors than they do lenses. But he was able to make some really, really good observations of the moon with his own telescope, just being able to zoom in a little bit and being patient and watching over time and taking detailed observations like a good scientist should. First thing he saw was that the moon was not smooth, which, you know, if you've ever seen pictures of the moon, you see like there's big craters from all the meteor impacts, and just a lot of damage has been done to the moon that would make it look not very smooth. Heck, if you were to look out at night, you probably would notice it has features, and those features make it look less smooth. But until Galileo made these detailed observations and took notes and made drawings, it was pretty well accepted that anything that was in outer space, anything that was beyond Earth, was a perfect smooth sphere, and he was the first one to show evidence that it wasn't. And it wasn't exactly easily accepted. Galileo had to deal with some stuff from the authorities. He was arrested quite a few times and then put on house arrest. Not because he'd robbed stores, not because he was being mean to people in general. It was really just because of his ideas. His ideas got him thrown in prison. But they were ideas backed up by his detailed scientific observations. Not only did he show that the moon wasn't smooth, he also made notes and observations about what were called the phases of the moon. Now, if you go out any particular time of the month, you'll see the moon as long as it's a clear night, and as long as you're out at the right time of night. There are times when the moon is not visible. That is entirely possible, and we're going to figure out why. But the moon does not look the same every single night. Sometimes it's brighter, sometimes it's dim, sometimes it appears that some of it's in shadow. Why is that? If you're not really sure what I mean, this is what I mean. Okay, this is the same mountain scene, and these are pictures taken throughout the month, one particular month, focusing on one region of the sky for a month to 28 days, probably a little short of a month. All right, notice the skyline seems about the same. Notice the the sunset is about the same, but the only thing that seems to change is the position of the moon at that time of day, and then how much of the moon appears lit up. Now, we all have maybe our own little thoughts on why the moon appears lit up in some times and not lit up at others. Maybe it has to do with shadowing, maybe it has to do with perspective, or maybe you have no idea at all. Well, we're going to figure that out. And Galileo was the first one to take a whole lot of observations and publicize them so other people could read them and have a better understanding. Before we get into the nitty-gritty of how, you got to understand that he had to come up with some names for what the moon looked like at these different points. Alright, and you could reference those names and people could conjure up an image of, oh, a moon with this much lit up, or a moon with maybe this part missing, or a moon that's completely illuminated. And those terms are things like this. So if we start with a full moon, the full moon is this right here, where it just looks like a ball completely lit up. Alright, simple, straightforward. The sun's light is reflecting off of that moon. Completely. As time goes on, we'll work from the full moon through what's called a waning gibbous moon. Again, a large portion of the moon is lit up, but there's this darkened sliver. Then a half moon, just like the cookie. Alright, maybe that's the easiest way to figure it out. Then a waning crescent. Then what's called a new moon. Now, a new moon is when the moon is up, but the moon is almost completely in shadow. It's hard to see, obviously, because of the position of the moon and how much light it's receiving. And then we have a waxing crescent moon, a first quarter half moon, a waxing gibbous, back to a full moon. This is a cycle of moon phases right here. But if you're like me, this image doesn't exactly help me understand why I'm seeing what I'm seeing when I look at the moon, and the moon looks different. What I want you to keep in mind is when you're making your observations of the moon, usually it's at nighttime. Now, I showed you in that very first picture, it's entirely possible to see the moon during the daytime. It doesn't just come out at night, it's just easier to see at night. But we're going to make reference to how the moon looks based on nighttime. It makes it a little bit easier. Again, this picture does not exactly help us as far as what we're seeing. So I have this little explanation to help us get a better grasp. I want you to know the phases of the moon as the moon makes its monthly journey around the Earth. So keep in mind, the Earth is here. Alright, this ball right here is not the sun. Okay? This is simply a representation of what we see. Okay? So the moon will go around the Earth, and it will take approximately 28 days to do that. Do you like my little drawing, the man in the moon? I always see that guy's face whenever I look up there. The side of the moon reflecting sunlight is viewed from different angles. That's what's really going on. So if the sun is over here, alright, and the moon is right here, then the part of the moon that is getting hit by sunlight is pointed at the sun and not pointed at the Earth. For that reason, we don't see reflected sunlight from the moon. I'm sitting here during the nighttime, and I look up, I'm just going to see this dark half of the moon. The lit half is pointed away. Now as the moon moves further around, notice now there's a tiny sliver of the moon that's lit up that is pointing towards the Earth. Here, let's see that sliver again as the purple line comes up. When that sliver is visible, I see this shape. It's called the waxing crescent. The waxing part means that it's more and more the moon is going to become visible. So as the moon waxes, you see more and more of the lit surface of the moon. As the moon wanes, you see less and less. All right, as the moon progresses around, now I'm seeing half of the lit side of the moon. Again, no more than half the moon is going to be lit at any particular time. It's all about how much of that half that's lit is actually pointed towards the Earth. Now we're getting over to here, all right, and we have a much larger section of the moon that's lit up that is pointing towards the Earth at nighttime, and we'll see this, our waxing gibbous. And eventually, when the moon is on the opposite side of the Earth, not directly behind the Earth, but on the opposite side of the Earth from the sun, we get that full mirror effect. We get the entire half of the lit moon pointed at Earth, and we see our full moon. All right, it's all about perspective. And as the moon continues going around, less and less of that lit up surface is going to be pointed at you and me, and we see less and less of the moon until we get to the new moon phase. All right, maybe this isn't helping either, so let's try something a little bit different. We'll be using this simulator right here. I'm a big fan of simulators. They help. So what I've done is I've selected the new moon phase. The new moon phase means the moon is dark. The part of the Earth that is seeing the moon that night is only seeing the completely unlit half of the moon. So if the sun is over on this side, the lit portion of the moon, that big reflective surface, is pointing directly back at the sun and not at all at the Earth. The dark side of the moon is pointed towards us. Typically, you don't really see it all that well unless it's nighttime, so, you know, you see that mostly during the nighttime. Now, as I play this, notice what happens. The moon's going to progress around its journey. The Earth is going to spin because, well, we spin on our axis. That's how we get day and night. And the phases of the moon are going to change. So, let's pause right here. Notice right now, we have a very, very small sliver of the moon that is lit up that could actually be visible from Earth. All right, what is that? Hey, that's going to be one of our crescents. This is a waxing crescent. As the moon moves on further, we're going to see more and more of the moon, the lit portion of the moon. Again, 50% of the moon is always lit up. Our phases just explain how much of that lit portion is pointed to where we can see it. Here we go. We're moving on, and now we're to a half moon. Why? Because we see half of the lit portion of the moon. As it moves on, during the nighttime, we're getting towards our full moon territory. Right here. Now, when we have a full moon, that just means the entire half that is lit by sunlight and reflecting sunlight is now pointed at the Earth, and we see that at nighttime. Your supermoons and things like that, they occur during a full moon. Now, the supermoon part just means, you know, the moon's a little bit closer, so it's going to appear about 12% larger and maybe 10 to 20% brighter, but it's always bright because it is reflecting all that light from the sun. As it moves on, again, we're spinning through day and night here, and what we see of the moon is really just all about what portion of that lit half we see. Now we're going through a waning gibbous, to a half moon, to a waning crescent, and working our way all the way back to a new moon. Now, hopefully that makes sense. This is what Galileo was observing. He didn't have a fancy simulator do it. What he had was time, dedication, and a telescope. He made some great observations that allowed us to understand a lot of what's going on out there. Now, hopefully the phases of the moon make sense. But that's not the only way the appearance of the moon changes as we move around our solar system over the years. There are some other things that go on having to do with the Earth, the Sun, and the Moon, and that's what we're going to talk about next. This weird phenomena that happens where we see a portion of the moon lit up and then slowly going away. But when I say slowly, I don't mean over 28 days, I mean over minutes. And that's going to be called an eclipse. So what is an eclipse anyway? I guess we'll talk about that next.